Good evening, and welcome to this evening's TI Technology webinar hosted by Texas Instruments, where you will learn how you and your staff can begin to implement topics in the Common Core State Standards using TI-84 plus C technology. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all students. I'm very happy to introduce our two panelists tonight, Marilyn Parker and John LaMaster. Marilyn holds a bachelor's degree in mathematics from Ohio University and a master's degree in educational administration from National University. She has taught algebra, geometry, pre-calculus, and AP calculus. After 23 years in the classroom, she took a job as a technology consultant for the Clark County School District in Las Vegas, providing technical support and professional development. She has trained teachers in online techniques and software. She has been using the graphing calculator since 1989 and has been a T-Cubed national instructor since 1995, speaking at many local and national conferences, delivering initial training and for third-party vendors. She also wrote the Easy Data Activities for Explorations book, which you may be familiar with. Thanks for being with us, Marilyn.
Hi, Mike. It's great to be here.
And John enjoys teaching mathematics at Indiana University, Purdue University, Fort Wayne, where he uses graphing technology daily to engage students. He has been a part of the T-Cubed family since 1993, presenting annually at conferences, promoting professional development workshops, writing math activities, and serving as a consultant for Texas Instruments, software, and products, including the TI-84 plus C Silver Edition. Thanks for joining us, John.
You bet. It's great to be here.
We are expecting a large crowd, so your audio is muted. Feel free to send questions using the Q&A window. We will use the chat window to send messages back and forth. For instance, if John or Marilyn is asking you a question and you want to respond to that question, go ahead and use that chat window. This session is being recorded, and as a reminder, you'll be provided a link to the event certificate of attendance at the conclusion of this webinar. Once the recording is available, if you'd like to follow along with your handheld or your software, and we really hope you will, we do recommend doing this with the recording so you can pause, rewind, and reflect using that recording as necessary. We don't expect you to have any issues tonight with your audio, but just in case you do, go ahead and select Communicate in the WebEx menu and then connect to Audio Broadcast, and that should take care of your audio issues. At this point, Marilyn is going to discuss our agenda.
All right, tonight I'm going to do a problem that incorporates some of the newer features of the TI-84C into a traditional quadratic equation problem. Then John is going to make your world light up using the new background image feature in this problem. We also have a handout for you to help you navigate through TI's websites to find lessons targeted to your particular class. And Mike will make sure you have a link for that after we're finished tonight. All right, John, you want to tell us what we hope people will take away from tonight's session?
Sure. So by the end of this evening, we'll see how that TI-84 plus, can I say it? TI-84 plus C can foster Common Core State Standards for mathematical practices. And we'll do this by looking at model building, making real-world connections, using the color and other new functionality that you can see listed here. And plus, we'll see how to keep the fun going after the webinar through the TI website and social media. So, Marilyn, let's start out the fun. And if you want to take us down to the farm, we'll see what old MacDonald is doing.
Okay. First of all, let's start out with a real quick review of the Common Core state standards. By now, most of us are probably getting somewhat familiar with them. If you are not, when you play back the recording of this session, you can pause on this slide. It's a rare lesson that will focus on only one standard. As we go through our lessons tonight, be thinking about which practices we are addressing. You can enter any that you see in the text chat window. Here's a quick overview of what I hope to get through tonight before turning things back over to John. Instead of using the built-in L1 through L6 list, we're going to name our list tonight. We're going to use formulas to fill some of the list, and then we're going to explain how to lock two lists together by using the quotation marks in our definition. All right, here's our standard fixed perimeter problem where we try to maximize the area. Remember, as we go through this problem, think about which standards we are using. Old MacDonald has 40 meters of fencing to make a rectangular pen for his pigs. If he wants to give the little porkers as much room as possible, what should the dimensions of the pens be? I've used this problem with pre-algebra, algebra 1, algebra 2, and even pre-calculus classes. How in-depth you go and how much help you give the students depends on their level of mastery. I put the students in groups, give them this handout, and tell them to work together to fill in the missing dimensions of each pen. I find this visualization helps the students conceptualize the problem. You'll be surprised how long it takes them, even the pre-calculus kids, and how slow they are at figuring out there has to be a faster way to do this problem rather than to work each problem independently. I let them work for a while, and then we come together to talk about it. I have this chart on my overhead, and we start filling in the missing lengths. After the first few, stop and ask your students for a fast way to find the length if you know the width. Matter of fact, right now, why don't you go to the text chat window and enter an algebraic expression for finding the length in this problem. If you know the perimeter is 40 and the width, let's say, is x, what would be an expression for the missing length? So I give the students a little time to work with each other, and I encourage them to work with each other. Some of them get it really fast, but I like them to just even be able to discuss, and if one kid doesn't know where the heck they came up with that answer, I like them to have the discussions themselves to help each other.
Yep, so we're seeing a lot of contributions in the chat with 20 minus x.
20 minus x, great. Most will start with their old formula for perimeter and follow their standard techniques to isolate the length on one side. But I try to encourage them also to think outside our standard rules to make things a little easier by saying this: if two of the lengths and two of the widths is 40, then one of the lengths and one of the widths must be what? On a good day, someone will come up with 20, and so we can get down to the length plus the width equals 20, therefore the length must be 20 minus the width. All right, we're going to switch over now to my calculator and do the rest of this. There we go. All right.
So I'd like to jump in. Since Marilyn just shared her desktop, and so now we can see her TI Smart View software, the chat, which you had just been using, and even the Q&A window in case you have questions that you'd like to have answered live, those two windows are now underneath that green floating toolbar. So if you'd like to still use those windows while Marilyn is working, then feel free to do so. And just as a quick reminder, I noticed that a few people in the chat window, there's a send to choice, and I think default is all attendees. The problem with that is that as panelists, say Marilyn, John, and myself, we don't see that response. So if you want us to see a response too, which we'd really like, instead of all attendees, send to all participants, which is, I think, near the bottom of your choice list. So Marilyn, I'm sorry, it's all yours.
No, that's great. Thank you, Mike. I appreciate it. All right, whenever I'm starting a problem, I like to go in and check my mode settings first. All right, and usually I start off, even if I'm not going to be using the defaults throughout the whole problem, I start off making sure that I have the defaults set. Basically, it's all the left selections, and that way the students and I are all on the same page. All right, now I'm going to go to my list editor window, so I'm going to go to Stat, Edit, and I'm going to enter all the list from, seriously? Really?
What I love, though, is that you've got some nice text on that message that wasn't just, a big kick out the door. That told you a little bit about what the error was.
Yeah, but you know what, we were practicing earlier, and now my stat plots are off. And of course, all these things, none of this happens to you when you're in your practice session. So I'm going to tell it here. The nice part is usually it tells me.
Yeah, if you hit the go to, maybe there's.
I hit go to.
Yeah. And so.
I see why. I see why. All right, hang in there. Oh, that's so mean. All right, I'm going to tell it. I erased something when we were practicing.
Covered. And then...
Huh?
Yeah, we love technology too, Mark.
It always happens. All right, we'll try this again. So I entered all the list, or all the elements from those little rectangles in list 1 here, and I did it ahead of time because I didn't want to waste the time in the class. All right. In general, I don't like leaving my list name L1 through L6 because you can write a program. A lot of different programs use that list, and they will overwrite it. All right, so to make sure it doesn't overwrite it, what I like to do is I like to name my list, especially if I'm going to use them more than one day, or I really like the problem and I'm going to save it. So I went in to make a new list. I'm going to highlight L1 or L2, and I'm going to do second insert above the delete key, and that gives me a blank column. Now, on the older 84 and the 83, as soon as you inserted a column here, your alpha lock would be put on for you. On the 84C, it is not automatically put on for you, so you're going to need to hit second alpha to put your alpha lock on. All right, and then I would just name it W. I'm going to make sure I name this one different than the other one. So actually, I think I'll just do WD. I'm just going to go because I don't want any chance. Now, notice after 5 letters, I get a little checkerboard cursor. That's an indicator that the most characters you're allowed to use to name a list is 5. All right, so now I've created this new list, and I'd like all my elements from list 1 to be placed in that list. So with the name of the new list highlighted, just press second L sub 1 and press enter, and it'll fill it in for you. All right, now again, just in trying to save some time, I already have my list entered in lists in length and width. When you're on this display screen, if you have a name of a list highlighted and you press your delete key, you're not deleting the list from the memory of the calculator, you're just deleting that list from the display screen. All right, I created 2 other lists in the same manner, and I named them length and area. But when I went to define them, I defined the length. I used what the kids had told me, 20 minus the width. But notice that in this definition, I have quotation marks around the definition. And what the quotation marks do for us is if I were to make any change to the width right now, these 2 lists are locked together, and same way with area. If I went over to show you the definition that I put in there for area, they're in quotation marks. So any change to the other list will automatically be carried through. Okay, now I'm looking at these lists, and I like the width. Well, first of all, let me tell you, notice how I put in my fractions for the list, 11 1/4. Again, that's something that's relatively new. Let's say that was a 7 here, and I just want to show you how I got that 11 1/4. Okay, so I'm going to hit my alpha key, and the new menus along the top row, so F1, shows me fraction templates. So I want to put in the mixed number 11 1/4, so I'm going to go down to number 2, and it just gives me the template, and you can see where your cursor is blinking on and off. Use your navigation keys to get to the different parts of the fraction. When you want to go to the denominator, you can either use the right arrow or the down arrow. They'll both get you there. And as soon as you press enter, that selection will be put into the list. And then because my lists were locked together, the length and area lists were automatically updated. Now I look at my length and area and I think, oh, shoot, look at those crazy looking fractions. I wanted them to be the mixed number like the width, all right? The width was a mixed number because I went and chose the template. But when the calculator is filling in, because when I filled in length and area, I did it with a formula, when the calculator is filling in from a formula, it uses your mode settings. So let's go back to mode and take a look at what we said we wanted the fraction type to be. We said we wanted the fraction type to be just the numerator over the denominator. So what I'm going to do, because those numbers are way too big for the kids to even make sense of, so I'm going to go over to the right one space so it looks like a mixed number, press enter to make sure that it is definitely selected. Now let's go back and look at our list again. And now I have really nice numbers that look like something that might make some sense to the kids. All right, let's go set up a stat plot. So just like before, second y equals. I'm going to turn on the plots. And again, I have this entered ahead of time just to save us a little work here. All this is pretty much the same as it used to be until you get down to the mark. Okay, for this particular problem, I like either the hollow square or the little plus sign. And then the color, if you go down to that, you use the right or left arrow color or keys to pick what color you want. I like to pick blue for this particular one. All right, so let's just take a look at what this looks like, but I gotta make sure my window is set right, so I'm gonna go to zoom, and again, this part is just like it's been for years and years. Go to number 9 for zoom stat, and there I see my graph. Now, if I trace, I'm used to things going from left to right, so I start hitting my right arrow key, and then all of a sudden, instead of going left to right, it's going right, then left, then right. It's going back and forth between all the different things. It's not going in order, all right? In general, the order that you get when you trace plots is based on the order that your elements were listed in back in the original list. So if I go back to stat and edit, I see in my width, I start increasing 4, 8, it gets bigger and bigger, but then look, then I go down to 6, then 15.5, then 9.5. So I need to sort the width. And now this is where it's really helpful that the length and the area are both locked in with those quotation marks. So if I make any change to the width, it's going to automatically update those other lists also. So I'm going back to stat, and number 2 is sort in ascending order. And I want to sort, now when you're doing the named list, okay, they're under the list above stat, so second list, and it's in alphabetical order after the original 6. Well, the one I want is called width, so it starts with a W, so I don't want to be bothered going down, 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 down forever. So I'm going to press my up arrow key here, and there I see width is my bottom selection, and these are called wraparound functions, okay? So if you know what you want at the bottom, just hit the up arrow key. So now I want to look at my, actually, you know what, I'll just go to my graph, and I'll hit trace, and now look, sure enough, it started on the left, and now I keep going, and it goes across to the right. Now, remember what we're trying to do here. We were trying to find the biggest area. So when I come back, I see here the biggest one that I have in my picture is when the width was 9.5, the area turned out to be 99 7/75. But is this really the biggest area? Okay, well, let's fit an equation to this and see what else we can get here, because maybe the largest one is not one of the plots that I happen to have picked out. All right, so I'm going to go back to stat, and this is just like it was in the old calculator, okay, and I'm going to choose number 5 for quadratic regression. And again, you have to pick, the default would have been to have L1 and L2, so I'm going to pick the width and the area for my X and Y list and bypass the frequency list. Here's another shortcut with the newer version. Okay, when I want the regression equation, we used to have to go into bars and then over to Y bars, but now you can go alpha, and above the trace key in F4, you're going to see all your Y equals. All right, so I'm just going to pick number 1 here, go down to calculate, and tell it to fill it in for me. Now, on the home screen, it shows you, okay, so this is basically the equation it says is the best fit is negative 1x squared plus 20x and then a c value of 0. If I go over and look at my y equals window, oh my gosh, look what I got. Instead of negative 1, I got negative 999 repeating for a very long time. And this is one of the things I like about this problem because it emphasizes that we've still got a few rounding errors. And this calculator, although really incredible, it's only as good as the person using it. Now, before I go look at my graph here, you know what? I plotted those points with a blue color. And when I'm doing the line of best fit on a problem like this, I like to pick a really contrasting color from the point. So I'm going to have my line here be magenta. Then use on any of the menus, just use your up, down, right, left arrow keys to navigate through them and click OK. And let's go take a look at our graph here. Oh, it's beautiful. And you can see what a perfect fit it is too. All right, and I think I'll go look at my table. So above graph, second table. And now here's one of the new features. Because we chose pink for y sub 1, when I go and look at the table, all the elements in y sub 1 are also pink. That becomes really helpful if you have more than one equation graphed at the same time. So when I look here, I see that the 10 and the 100 are the greatest area being shown here, but is that really the biggest one, okay? Because maybe it's not. Maybe it's 9 3/4, or maybe it's 10 and 1/4. You know, I don't really know. So I need to go find out. All right, so I'm going to let the calculator help me out here, and I'm going to go to second calculate above trace, and I'm going to ask the calculator to find the maximum for me, okay? Now, when you hit that maximum, it's going to ask you for 3 things, the left bound, the right bound, and then a guess. And I tell my kids, especially on this, on a quadratic, when you're looking for the vertex, for the left bound, you are better to be way too far to the left than to risk any chance of being to the right side of that vertex when you're looking for the left bound. So I'm going to move definitely to the left. Press enter to select it, and then it changes the question and asks me for a right bound. And I'm going to do the same thing. I'd rather be way too far to the right than to risk any chance of being to the left when it's looking for a right bound. And then it asks me for a guess, and it really doesn't care how bad of a guesser I am, so you don't have to spend a lot of time trying to get exactly right on the vertex. Just get anywhere between those two. And here we go again. This is another reason I love this problem. You'll find, depending on what the students choose for their left bound and their right bound, it's unlikely that they're all going to come up with the same exact number for the maximum. Sometimes it'll be lower like this with the 9.99 repeating. Sometimes it'll be 10 point, you know, a little bit more than 10. But I'm trying to emphasize to the kids that one of the things I want them to do is give me the mathematics that backs this up. This is not a cure-all. It's only as good as the person using it. And I tell them ahead of time, if you write down on your test that vertex happens when the x value is 9.999, I'm going to take some points off your test because that is not, you know, a right answer. I want to know that you know what you're talking about. So I'm going to ask the kids then to come up with you know, the mathematics to back it up. So I want to see them go through the whole standard. You know, what the heck did we do here? Area was length times width. Our width was just our x, and then we took our length was 20 minus our, I want to see all this work just like always. I want to see them tell me they know the vertex is negative b over 2a. So I'm never willing to abandon the mathematics in favor of just the technology. I want the two of them to go together. And just a little side note, if you're ever graphing an equation, because you can see sometimes you'll have some extra things graphed and it just takes a while and you don't feel like waiting for it, or sometimes you might want to just stop before the whole thing is graphed and have a discussion with the kids. Pressing enter while a graph is being drawn will pause the graph. Then you just press enter again when you want it to restart, okay? But you can't do anything else until it finishes being drawn. If you want to stop it in the middle so that you can go do something else, you need to press the on key, and then you're going to be allowed to exit and go back to any screen that you want. All right, how are we doing over there, John? Are you ready to take over?
I am. So, but I also share your insistence on I will not take a .999 repeating. So I'm glad to see there's another one out there.
Well, and I like to find problems like this that bring that up so they run into it in a regular classroom discussion. I don't want them to run into it the first time in the middle of a test.
Excellent. So you're going to throw the...
Yes, I am.
Great.
It's all yours.
Okay, and I am going to... I have the ball. Mike, I might need your help in finding where my share is.
Sure, John. It should be at the very top of the WebEx menu.
Okay. Yeah, there it is. Thank you very much. Voila. And what we see here is a bit of preamble here with our Common Core standards that we're going to look at another classic activity that involves geometry and coordinates. And you can see this is what we're going to actually look at, the effect of dilations and so forth. It's the part A of the three parts. There's some activities. We mentioned that there's a handout already that you'll see on how to get activities. This activity's been around a long time, and so they are shifting and playing with a triangle here. In this transformation activity, they're using an arrow. And all you'd have to do is just go up to the top of the menu, and in the search box you could put in transformation with lists. But I wanted to show you that what I'd like to do is show you that there are other ways to do this that will enable you to enhance this activity with the 84C. So here we can see a tree, and here's Ruth Casey did a neat fish where they took the points onto a grid and then got the coordinates. Well, we're going to do that same thing, only with a starfish, and this activity has a handout that you'll see this exact handout in your downloads. That Mike will share that at the end, where we'll have all the steps, and then we're going to walk through that. So we'll start off with using this digital image, and that's where we can actually then enhance this in a way that we couldn't before. First of all, what I'd like to do is just make sure that if you're following this along later on the recording, you might want to reset your defaults, and it's a nice idea just to show that that's very nice when you have an 84C more handily than ever, because there's new features on it that I like to reset. And that, I go to the memory key and number 7, where I then hit the enter button, press the enter button, and I have to either press the down arrow button a couple of times so that I get to the reset. So I'm going to reset my calculator before the activity. And what did that do? But pretty much made it look like the way it would be when it came out of the box with a standard window. And then the format was all in good shape. And this format screen, if you've not seen an 84C before, has some fun stuff on it we're going to use. We're going to go and down to the background. I'm going to go to put a background image on there that's that starfish I showed you. And what you'll see is there's some built-in images already. This is a leaf, or a flower petal, a water fountain, and here's our starfish. And there's room for more images, actually, on here that you can put on as well. And just to make sure you are aware, you can get a handout at the end that'll help you go through the steps on that as well. So we've got a starfish as our background. For fun, since we're going under the sea, why don't I make my border color a little blue? And I'm going to turn my axes off. I can do that by scrolling through with pressing the left arrow key a couple of times. And now I have my format screen the way I want it. And so when I press graph, I'll see this. But let's get a good window. And an easy window that I like is the decimal window. And I'll tell you a couple of reasons why I like it. If you remember the standard window, it had these steps when I traced or when I pressed my left arrow on the graph screen of these ugly numbers. So when I press zoom and go to the decimal window, that will change. And it'll have the same functionality as an 84, but these settings will look a little different in terms of the numbers because the screen's a lot different in resolution. But down here, you can see the trace step has turned into a friendly decimal step. So we're ready to go. If I press graph again, I'll see my starfish. Now, remember, the old activities that are out there required me to get the points written on paper and then put them in. Now, what I can do is simply just drop them right onto the digital image. And here's how to do that. We're going to take and go to the Stat menu. And to the right arrow, we're going to do it in a different way than you might expect. We're going to go to the very bottom of this Stat Calc menu. Here you see linear regressions. We were just there. We're going to press the up key to get to the very bottom, and we'll see Quick Plot and Fit EQ. And that actually drops points, and that's in fact the first cue there, drop points. And the decimal window turned out to now see as I walk, I get nice little steps and increments. And I'm going to notice, though, that its default is blue. Here is a place where I can change the color of the points. If I press the graph key, I get the style. I can change by pressing the right arrow my color. And I may want a little bit more of a color to match the picture, so I'm going to do that. I'll change my color. And if I had forgotten, I actually have a opportunity to fix that later. So that is where I'm going to start dropping points. Actually, I'm going to go down below just a little. And I'm going to make a first point here just a little bit below. I'm going to hit Enter, press Enter to actually plop a point on the starfish. I'm going to have a stick underneath him, so he's a starfish on a stick. I know I'm kind of strange, but it'll help make my image be a little more unique. And now, what my goal is, if you remember, Marilyn, you had nicely shared with us how the way you plot the points is the order in which they'll be shown on the screen. And these are actually dropping points into a special storage area on the calculator that I can then ask to be put in my list. And I want to do this in order as I walk around. And so as I do this, I'm going to ask for your help with the chat. And Mike, can you share with us again, how do we get the chat now that I've shared my desktop?
Sure thing, John. So if you move your mouse cursor underneath that green tab that says Viewing John's Desktop, then you should be able to click on the chat icon. And just as a reminder, there's a Send To feature. I think the default, again, is all attendees, and we actually are looking for all participants. So just choose in that drop-down menu all participants, and John, that should be it.
Okay, great, thanks. So what I'd like is, here's an image that is a photo. We can certainly put our own photos in. What kind of photos or images might you put in for your students that would be particular to your place or that would really engage them? We're using a built-in image just for simplicity, but we can make anything we want. We've already seen we've had so throw ahead your ideas in the chat, and we can see what kind of brainstorming we can do, get our teacher energy. One of the things that's neat is I've seen a flag get sent, and I've seen, well, long ago I used to do Darth Vader. I put him up here. And the student stretched his face all over the place. It was a riot. So I see some of the things in the chat. A school mascot, that's a great idea. Spoked wheel, all right, marvelous. Spider web, oh, beautiful choices there. So thank you for your ideas. And as we get there, we're almost at the end here, and you can get as particular as you wish on this, on these details. I'm going to see that I probably would do better surgery if I weren't live over an internet connection and on a recorded webinar, but I'll do my best here to give Mr. Starr a makeover. So I'm going to enhance his beauty, and what I'd like to do, though, is if you've noticed, I stuck him right there at the beginning. I'm going to just nail that point right. I probably shouldn't say it that way. I'm going to put that point right there at the very beginning point, and now I'm ready to fit equations here, which is a silly thing to do. We're not going to really fit an equation. But let's see what's under that menu. Is they give us these choices, and we'll ignore whatever we want. We just really want the points stored. So I'll hit number 2. And it fit an equation, and there's the equation. You see it up there, but the best part of it is store. So we're going to go to the next step, and it asks us, put it in L1 and L2. We like that. Make it in plot 1. We like that. We have to go all the way to the down, using the down arrow, the navigational down button, to hit OK, or it'll all be for naught. So hit OK, and it's storing it right now and regraphing it. And let's see what it did. Well, because we asked for it to be in L1 and L2, there we'll see it right there in L1 and L2. I'll give you a secret. It actually had it in a temporary spot called QP for quick plot X and QPY. So we have it in 2 places hiding. But that's just, undercover information. Now let's get the plot. So to do that, we need to press second y equals to get stat plot, and it followed our settings. It made a scatter plot. It turned it on. We want these connected by line segments, like our other activities that we've seen. We kind of like L1 and L2, but I would like that little blue, I like that dot, that smaller marker, not the big one. And as mentioned earlier, you can change the color right here if you didn't like that from the style. So we'll press graph, and there is, oh, I forgot to do something else, which is always great to do, especially in front of a live audience. I forgot to clear this out. And did you notice that we don't get a bunch of 10 decimal places when we do quick plot and fit? That's kind of nice. It kind of makes it a small, compact little shortened version. The Reader's Digest version of the linear regression. And there's our little star. So let's make more starfish. And we're going to, thanks, Mark. I did want to clear it. Where were you when just my room, Mark. All right, that was good. I need Mark right here. All right, so appreciate your help. I'm going to make some more by transforming the coordinates. So we can do that right in the list editor, as Marilyn did, but we have to be careful because we're going to stick a new list in, and I don't want to stick it there. Where is that cell? So I have to climb up to the tippy top shelf, and I'm going to make a little starfish by, well, I probably shouldn't have said it that way. I'm going to multiply every one of those x coordinates by a half, and every one of those y coordinates by a half, and make sure, again, I'm on the tippy top shelf. That's a place where things can go bump in the night. And watching, though, that I also have that backup place because I have that extra place where I stored QPX and QPY in case something does go wrong. And what is neat to see is to look at what changes and what doesn't change. So you can take half of 0, and it didn't change, but half of -3, indeed. We can see kind of then looking at this structure of what happened to each data point. And now, it won't really make much of an impression unless we turn the plot on. So we're going to go to plot 2, as we did before. And I've set this up already in advance, but you'd want to, I'm going to make him a little magenta to liven up the screen. And there is, I'd like to call him Little Patrick. I agree. Nancy, this is where you would probably bring in that Common Core and say, okay, I'm going to multiply this and multiply that. What do you think will happen? And in fact, I might stop and say, okay, are these two shapes, what has stayed the same? What is different? So we could list on the board, okay, those angles seem to have stayed the same, right? Are they similar? Leslie, good job, right. So congruence versus similarity, you know, and so, and yeah, did this surprise you? I love it. Do you think the perimeters, how are the perimeters different? How do you rotate? That's a great question. We want to probably bring in a trig function, or multiply it by a sign, or use some vectors. I would like to do one more thing. I'm going to, well, I have a couple more fun things to do. Okay, did the areas change? I like that. Yeah. So let's take and multiply by a number bigger than 1. And so we'll do 1.2. I've rigged this just a little bit because of the screen change. The screen is a decimal window. So I'm not going to multiply by 200 or something and then have it off the screen. So 1.2 L1 and 1.2 L2. And now here again, you want to say, what do you think will happen? And here we have, press the graph. And, well, we have to rub the lamp for us to see what happens. Oh, better go into second stat plot. And we're going to turn that baby on. Oh, here's a cute way. Since it's already set up, I can just go and impose hands up here on plot 3 and just, you know, there we go. And it is, I don't know about you, just look at that. Gorgeous. Hello, gorgeous.
It's
you know,
beautiful.
Yeah, we got these lovely dilations. We can see how many little Patricks can fit in the blue mama and fit in the blue, in the yellow daddy. So we can get those kind of fun kind of questions, or ask the students to come up with questions, you know, and so as they drop those points, they can get in. What you probably want to do is, you know, consider a, where you can take a, let's go back to that stat plot, and if I wanted to change only one piece, so I've got L5 and L6 as Big Daddy, so I'm going to change him. I'm going to make him 0.5 L1. So I'm multiplying all the x coordinates of little Patrick by a half. And let's see. Actually, I'm looking at my notes, and I was in the wrong place. I'm going to do this. I'm going to multiply little Patrick, ignore that earlier, by 4. So his x coordinate is, I'll do it right, 4 L3. It's great to actually do it right. So I'll pause there. So I want this. This is his x coordinate of Patrick. I'm going to multiply his x coordinate by 4. hit enter to say please, and then I will have his y coordinate be, why don't we see what happens if we, and here's where your what ifs are. What would happen, and hopefully your students would generate this, say the negative of the original, and stop a moment and ask them to look at those coordinates. Yeah, it is a little fast, Mark, so but what you can do is you might want to see that when you climb up there, you can just type your formula, and I didn't use the quotes, but you could also do that. But if I look at L4 and L6, L4 is the y-coordinate, L6 is the yellow one's y-coordinate, and what do you notice? Then L3 and L5, and so there's 0.25 to 1, 0.7 to 2.8. So I'm hoping that they can see those comparisons. And now we've got it already on our graph. Let's take a look at what happened. Well, here's what you'd hope. You'd say, well, tell me what's going to happen. And then, you know, you're begging them to see. Can you rename the list? You certainly can. And I didn't, just because of interest of time, but we could put all of these into names, so there's many different ways. Oh, yeah, put a Klingon up here. That'd be great. So we can get them to see, hey, the vertical change has been flipped. And actually, what's kind of neat is if I went even to my second, I'm going to just go to my y equals and turn off mama, because she's in the way. And we'll see that I just have Patrick and his original. It's interesting, sometimes just even press trace, and then the down arrow will move to the corresponding point. So we could ask them, what do you think, without looking at the list, what do you think that corresponding point is? Remember, you did 4 times the original, 4 times the x, and you minus the original. And then you can go around the horn and find other points that you might want to do that with that are maybe a little friendlier. So then I'll just down arrow, so I'd expect this to go to 4 and then negative 0.15. So you can see other ways you can get them to predict and see that coordinate of the lovely starfish family. This is fun. You could simply, I'm going to point out that you could simply create a transformation behind the scenes that they won't see. Like you could turn off your overhead, you mask your overhead screen. I can't do that on the webinar, but I have a little program here that is got information in it that moves Patrick. And I would like now see the other way you can get the Common Core math practices is tell me what I did. What did I do to get the transformation? In fact, perhaps the chat can offer the answer. I put the grid line on in the program, but I also can do that simply by going to the Format menu. I won't change this. I guess I can change the view cube a little, and we can see the view cube will show everything while I'm still working. That if I hit second format, I just highlighted the grid line there. So what did it do? So how did it change? How did the Patrick change from the to the yellow? Yeah, okay, cool. So, and what I might see then is how do I change the x and how do I change the y? Great. So you can then ask them to make that on their calculator if they've already have some of this as they were working with you. And the answer will be their calculator looking like yours. So that's really the ideal way to liven this up. And of course, if you've used images like a Klingon, you know, you can make a different image that'll strike them. One other thing, and Marilyn, I would like to maybe bring in a little bit of animation with this. So I'm going to actually share with you this program called StarWalk is actually in the handout. We make a simple program. I love it, Marilyn. Keep on playing. All right, and have him walk around and dance. There is really no sound coming out of the 84C. That is not a new feature. We rigged that. But the program is in your handout, but it's a way you can see how to get there. And I ought to share with you the program for the transformation was just really simple. I just simply did what you asked me to do: subtract 5 and add 2 to the x's and the y's. So we pretty much hit the time right on there, and I'm going to now give the desktop back. Yeah, that was StarWalk. It's the cute little, you know, the program for StarWalk really is very simple as well. I'm going to let you see that in the handout, though, and I'm going to give that to Mike, which I'm still learning on this, Mike. So you're probably
That's right. So, John, if you just stop sharing your desktop.
Oh, okay.
And then you should be able to give me control back.
I see.
It sounds like Mark's going to have a busy weekend ahead of him.
If you really want Mark, my Darth Vader, I'll send it to you or anyone. I don't know if we put our emails on. All right, so now can you just grab the desktop or?
No, John, you have to drag the little ball over in the participant panel. Give it back to Mike.
Okay. Easy for you to say. I don't see it on my screen, so I'm probably.
You have to stop sharing first, John. So if you just click the stop
sharing. You know,
sharing.
my kids have told me that before. All right. So I thought I'd just hit that, and you've shared more than we need. So you can see my screen, Mike. Maybe you can't. Share my desk. I thought I'd unclick that, and help. We're stuck in John's.
Yeah, I'll get you, John.
Okay. He's got the big wigs. Yeah. Okay.
Okay. All right. I did notice a few people, I think John and Marilyn, did want some contact information. So if either of you don't mind, maybe putting your email in the chat window.
Absolutely. Happy to connect.
Thanks, guys. I appreciate it. I know everyone else is looking for more information. And on that note, again, just as another reminder, all of the documents that Marilyn and John did use tonight, you'll be receiving here in a few minutes, as well as you're going to get an email in a few days that will definitely contain a link to the recording, so you can watch that a few times if you need to, because there's a lot of really good stuff that John and Marilyn went through, and I think it might take an extra second just to sink in. Especially, I like some of the comments in the chat window. And so you should be able to see the chat window as well in the recording. I do want to bring you to a few resources that we have available on our website, which again is education.ti.com. And if you slide under professional development and scroll down to online learning, I want to highlight the tutorials, which is on the left-hand side. And then if you go, we have a few different choices here. We're not looking at TI Inspire tonight. We're looking at other graphing tutorials. And here we have Atomic Learning Tutorials for the TI-84 Plus C Silver Edition. And right below that is Atomic Learning Tutorials for the TI-84 Plus Silver Edition. So maybe you haven't gone out and bought the Plus C yet, or your students haven't done that, and you're still currently using the 84 Plus. So we still have some resources available for that as well. And what the Atomic Learning Tutorials are, we have a good partnership and friendship with Atomic Learning, and they've helped us create just really short videos for the TI-84 Plus C and the TI-84 Plus. Anything that you kind of think of that sometimes you're sitting in class and you're like, oh, I need to remember how to clear a list or something along those lines, and it's just getting you. So if you're a beginner, or certainly I think even an intermediate user of the 84 or 84 Plus C, some of these short videos might really help. And again, you can see they're all 2 minutes long, 3 minutes long. This is all free, and so you can pause and rewind as necessary. Also on our webpage, on the left-hand side, you'll see the Webinars tab. And I think John and Marilyn really did a great job tonight of sort of bringing some ideas that you can use in your classroom, bringing together Common Core and the TI-84 Plus C. And again, maybe, especially if you're a new user to the TI-84 Plus C, it might behoove you to check out the on-demand section of our webinars. And if you scroll down in August, we had a webinar that was back to school with the TI-84 Plus family. And during this webinar, we sort of went through some ideas and tips and tricks to dust off some of the cobwebs that you may have gained this past summer in using your technology. And I know some of you are probably really proficient with the 84 family, but I know that there was a couple things in there that I never thought of, one of which that I'm impressed with still is one of the panelists discussed using parametric equations in Algebra 1 and to discuss distance time problems. So if that's something that might interest you, please feel free to check out that Back to School with the TI-84 Plus family. I think it's a really nice event. And there's a few others as well that are available on demand. We have a new initiative called STEM Behind Hollywood, and it's a really exciting new program created by us, TI, with the assistance of the Science and Entertainment Exchange, which is a program of the National Academy of Sciences. And its goal is to get your students excited about STEM education and careers. And what happened was we had scientists and experts who consult on Hollywood films and TV, worked alongside leading math and science educators to create free classroom activities for TI technology. I know one of the most recent ones dealt with zombies. So what can we learn from zombies that can help us learn about the human body itself? So it's a really kind of neat initiative that I think you can probably check out, and your students will definitely be engaged using some of those activities, and you can learn more at stemhollywood.com. As you know, TI does support and offer other strategies to use the Common Core state standards in your classroom, whether it be middle grades or high school. And we are continuing to develop other ideas and activities to help support the Common Core state standards